Welcome to Educator.com. Today we're going to be graphing inequalities with two variables. First, we're going to discuss what to expect, what the graph of an inequality with two variables looks like. And the graph of an inequality in two variables is a set of points that form a half plane. The boundary of this half plane is a line determined by the equation corresponding to the given inequality. So let's break this down. If you are given an inequality, you can find the corresponding equation, and when you have that equation, you can use it to graph a line. So let's say my line comes out looking like this. One note that we'll discuss further in a moment is that this line may not be solid. It may actually be a dashed line, and I'll explain that in a moment. When you put a line on a coordinate plane like this, it divides the coordinate plane into two half planes. Right here, and continuing on, would be the upper half plane. Below the line is the lower half plane. One of these half planes will contain the set of points that is going to be the solution for my inequality in two variables. Therefore, in order to graph an inequality in two variables, you're going to need to find this line, and you're also going to need to figure out which half plane contains the correct set of points. Right now, though, I'm just talking about, in general, this is what the graph is going to look like. And you're going to either take this area in black or the one in red, one of the half planes. Therefore, the technique is going to be to first graph the equation corresponding to the inequality. One thing you're going to note, as I mentioned, is that if the inequality is either less than or equal to or greater than or equal to, if it contains this equal to, the graph of the equation is a solid line. If the inequality is less than or greater than, a strict inequality, the graph is a dashed line. For example, working with just a very simple inequality. If I have the inequality y is less than x plus 1, my first step, step 1, is to graph the corresponding equation. That corresponding equation is y equals x plus 1. And this is conveniently in slope-intercept form. Since this is slope-intercept form, I know that my y-intercept is 1, and the slope is also 1. That allows me to graph this line. Before I graph it, I need to know what the line is going to look like. It is actually going to be a dashed line. So since I have a strict inequality, I'm going to use dashes to represent the line. My y-intercept is right here at y equals 1, x equals 0. And then I know the slope. I know that when y increases by 1, x increases by 1, because I have a slope of 1. And I continue on, so then when x is that's going to be x is 2, y is 2. And then I'm going to go on increasing x by 1 and y by 1. So I had y is 1, go up by 1. That's going to give me the point 2, 1, 2. And then increase again, each of these by 1 and on up. And I could also do that going back down. This will allow me to form a line, but because it's a strict inequality, I'm going to use a dashed line. What this dashed line is telling me is that the points on the line are not part of the solution set. If I had a solid line, for example, if I had y is less than or equal to 2x plus 3, then when I found my corresponding equation, I would graph it using a solid line. Here, For my second step, I determined that I needed to use a dashed line. So my technique for graphing is I graph the equation corresponding to the inequality, and I determine that it needs to be a dashed line. In my second step, I need to figure out which half plane contains coordinates that will satisfy the inequality. That is done by choosing a test point. For example, I could again use the one we just discussed, y equals x plus 1. And we've already graphed out that line, so let's just continue it right here with this dashed line. That was the equation for the line, and the inequality was that y is less than x plus 1. So that gives me the line. Here's my inequality. What a test point is going to do is it's going to allow me to figure out, do I want the upper half plane or the lower half plane? And the easiest test point to pick is 0, 0, the origin. Therefore, what I'm going to do is I'm going to go back to my inequality, and I'm going to let x equals 0 and y equals 0. And I'm going to determine if that is true, if it satisfies the inequality. So I have y is less than x plus 1. I'm going to insert 0 is less than 0 plus 1. 0 is less than 1. So I look at that. Is that true? Yes, it is. So does 0, 0, does this point satisfy the inequality? Yes. That point, 0, 0, the origin is right here. What that means is that the origin satisfies the inequality, and that this lower half plane is the solution, is the graph of the solution set. Okay, so again, if I have an inequality, y is less than x plus 1, I graph my line, y equals x plus 1, which we already did. I used a dashed line because it's a strict inequality. Then I chose a point, and I decided to choose the origin to keep my life very simple, and inserted those values into the inequality. So 0 is less than 0 plus 1. 0 is less than 1. That is a true statement that satisfies the inequality. Therefore, the half plane that that test point is in is the correct half plane. Putting this all together, you need to first graph the line that forms the boundary of the two half planes. You need to determine if the line is solid or dashed, and then you need to use a test point to figure out which half plane contains the solutions. Okay, graph y is greater than or equal to 3x minus 4. I'm going to first graph the line by finding the equation, which is y equals 3x minus 4. This is in slope-intercept form, so I know that my y-intercept is negative 4, and I know that my slope is 3. That makes it pretty easy to graph. I'm going to go down here at negative 4. That's my y-intercept, and then I'm just going to use my slope to find another point. When the value of y increases by 3, 1, 2, 3, the value of x increases by 1. So negative 1, 1 is my second point. And I could continue on and find other points just by using this slope-intercept method, but this is actually enough. And now I'm going to draw the line. And you notice that what I'm doing is drawing a solid line. And I'm drawing a solid line since I have greater than or equal to. And it tells me that the points on this line are going to be part of the solution set. Okay, I have the line. Now I have two half planes formed by this line, but I don't know which one is the correct half plane. So I need to pick a test point. For my test point, I'm going to use 0, 0, the origin. I go back to my inequality. and I'm going to plug those values in. So 0 is greater than or equal to 3 times 0 minus 4. I end up with 0 is greater than or equal to negative 4. Is 0 greater than or equal to negative 4? Yes. So does this test point satisfy this inequality? Yes, it does. This test point satisfies the inequality. Now let's go and look at where the test point is in terms of these half plane. This test point lies in this half plane. Since that point satisfies the inequality, I've got the right half plane. So I'm going to go ahead and shade that in, indicating that that is the correct half plane. Now, if I had come up with something that was untrue, it did not satisfy this inequality when I put in 0, 0, then, and I had to say no here, then I would pick the other half plane, the half plane where my test point wasn't. But since it did satisfy it, I pick this. So the 3 steps are to first graph the equation. Graph the equation that gives you the boundary line for the 2 half planes. And as you're doing that, you're looking and seeing, do I want a solid line or a dashed line? And I want a solid line because it's equal to. So this is part of the solution set. Next, I'm going to pick a test point, 0, 0. And since that did satisfy the inequality, I go ahead and choose the half plane that that test point lies in as my solution set. We're going to do the same thing here. First, I'm going to find the equation that corresponds to this inequality, which is going to be x minus 3y equals 4. Now, I want to put this in slope-intercept form so that I can graph this line. So I'm going to divide both sides by negative 3 to get y equals x over 3 minus 4/3. So what this tells me is that my slope-intercept is, my y-intercept is negative 4/3. It's in slope-intercept form. And my slope is 1/3. Okay, so my y-intercept is actually negative 1 and 1/3. Negative 1 and 1/3. It's right about here. That's my first point on the line. And I could find another point, or I could just go ahead and use my slope. Either way would be fine. I'm going to actually find the x-intercept, since I think it'll be easier than working with these thirds. So what I'm going to do is I'm going to let x equal 0. Excuse me, let y equal 0. Let y equal 0 to find my x-intercept. So I'll go up here, and x minus 3y equals 4, or x minus 3 times 0 equals 4. X equals 4. So that gives me a second point of 4, 0. So I have 2 points that I can graph. I have 0, negative 1 and 1/3 right here, and I have 4, 0. All right, I found the points to form this line. My second step is to say that this is a dashed line. It is a strict inequality, which means that the points in the line are not part of the solution set. Okay, so I have a line, and I'm going, actually, slightly change that a bit. That is actually negative 1 and 1/3 right here. So this is the line I will come up with. So I've got, my first point is 0, negative 1 and 1/3. And then my second point is 4, 0 to give me this line. Now, for my test point, I'm going to use 0, 0. I'm going to insert it into this inequality, which will give me 0 minus 3 times 0 is less than 4. 0 is less than 4. Is 0 less than 4? Yes, that is a true statement. Yes, this is a true statement. Since my test point satisfied the inequality, I know that the half plane that this point lies in contains the solutions. So the upper half plane is the correct half plane. First, graphing the line, I found my y-intercept and my x-intercept. I graphed the line using a dashed line because it's a strict inequality. I used 0, 0 as the test point and found that when I used the test point, my inequality was satisfied. So that test point must be in the correct half plane. So I shaded that in. In example 3, we have 4x minus 3y is greater than or equal to 12. My corresponding equation is 4x minus 3y equals 12. I can go ahead and put this in y-intercept form, so I can graph the line. Y equals minus 4x plus 12. Dividing both sides by negative 3 gives me y equals 4/3 x minus 4. So my y-intercept, my first point, is going to be 0, negative 4. I'm also going to go ahead and find my x-intercept. I'm going to let y equal 0. I'm going to go back up here and let y equal 0. So I get 4x minus 0 equals 12, or x equals 3. So I have my second point. I have 2 points. I can go ahead and start graphing. 0, negative 4, 3, 0. Second, I look and I see that I'm going to have a solid line because I have this equals. This line splits the coordinate plane into 2 half planes. I'm going to use my test point to figure out what the correct half plane is. My test point is 0, 0. I substitute 0 for both x and y for the inequality. So 4x minus 3y is greater than or equal to 12. 4 times 0, that's 0 minus 0, is greater than or equal to 12, which gives me 0 is greater than or equal to 12. Is that a true statement? No, it does not satisfy the inequality. Since this does not satisfy the inequality, 0, 0 does not lie in the half plane where the solutions are for this inequality. So this is not the correct half plane. Instead, I'm going to go to the lower half plane and shade that in. Okay, so here's the line, the equation that will allow me to graph the line that bounds these 2 half planes, and that came out to be 4x minus 3y equals 12. I went ahead and graphed that out with a solid line because it is greater than or equal to. Then I used my test point. I plugged that into my inequality and found that it came up with 0 is greater than or equal to 12, which I know is not true. And that point is right here. So this point is not part of the solution set. So instead, I'm going to go down and shade the other half plane. In example 4, we're being asked to graph 2x minus 6y divided by 3 is greater than 4. And we have to assume that x is greater than or equal to 0 and y is greater than or equal to 0. So we have restrictions that x and y are both positive, which is going to affect our graph. But we start out the same, which is by finding the equation that corresponds to this inequality. So I have my equation corresponding to the inequality, and I'm going to multiply both sides by 3. I'm trying to put this into slope-intercept form. I'm going to subtract 2x from both sides. Then I'm going to divide both sides by -6 to give me y equals 1/3 x minus 2. So I have my first point because I have my y-intercept. So that will give me 0, 2 as my first point. I'm going to go ahead and find the x-intercept as well. So I'm going to let y equal 0. I'm going to plug it into here. 2x minus 6y equals 12. Substitute in 0. So I get 2x equals 12. Or x equals 6. X equals 6. Therefore, my x-intercept is at 6, 0. So I have my 2 points. 0, 2. Excuse me, 0, -2. And 6, 0. So that's my y-intercept, my x-intercept. I then see I have a strict inequality, so I know that I need to use a dashed line. Okay, the next thing I need to do is figure out which half plane my solutions are going to be in. I use my test point of 0, 0, and I go back to my original inequality. 2x minus 6y divided by 3 is greater than 4. So 2 times 0 minus 6 times 0 is greater than 4, and that's all divided by 3. 0 divided by 3 is greater than 4. So I come up with 0 is greater than 4. Is 0 greater than 4? No. Since that does not satisfy the inequality, that means that this point is not in the correct half plane. The thing is, before I start shading my whole solution set here, I have to stop and think. They're telling me that x is greater than or equal to 0 and y is greater than or equal to 0. The problem is, if I shade all this, I'm going to have a bunch of negative values for y. All these values for y are going to be negative. All below here. And if I shade way over here, I'm going to have a bunch of negative values for x. However, they're not allowing that. So what I have to do is only shade the part of the half plane that contains values for x and y that are positive. So remember, in the first quadrant, the values for x are positive and the values for y are positive. So I need the area in this half plane that also lies in the first quadrant. And since it says greater than or equal to 0, I am going to include this area here where y is equal to 0. However, I'm not including the points on the line because this is a strict inequality. So again, what I did is I found my corresponding equation, and then I found from that my y-intercept and my x-intercept. Graphed the line. Because it's a strict inequality, I used a dashed line. And then I found my test point and realized that this test point is not in the correct plane. I need to use the lower half plane, but I'm not going to shade the whole thing in. I'm only going to shade in this little wedge in the first quadrant because in that area, both x is positive and y is positive. So it meets the restrictions that I was given. That concludes this session of Educator.com. See you soon.